Hi, in today's video I'm going to be taking a look at setting up Bhyve on Freebsd to run virtual machines. What we're going to do is set up a Linux Ubuntu virtual machine. We're going to install Podman, and then we're going to install Invidious, which is an open source alternative front end to YouTube. And we're also going to create a Lua script for MPV, which we can use to play the videos from Invidious without using yt-dlp in the back end. So MPV uses yt-dlp to get the URLs for videos from YouTube as well as Invidious, and there is a 5-second delay while it completes a capture challenge using deno. So what we're going to do is actually set up Invidious. We're going to have a keyboard, a hotkey using wlr-which-key, which will allow us to trigger a emacs function that will actually rewrite URLs from YouTube to use Invidious instead. And this will allow us to actually play the videos quicker. And what we're also going to do is actually create a Makefile to start and stop the VM. So instead of manually starting the VM, SSHing into the VM and running a script to start Invidious, and then having to manually shut down the Podman container and shut down the VM, we're going to have a simple Makefile which will actually automate the process. So we can just run make and it will start up the VM, then SSH into it, run the script to start Invidious, and then when we want to stop it, we can just run make clean and it will stop the VM. So let me get started and actually show you this in action. So what I'm going to do is actually make this bigger. So what I have here is a Makefile, which I'll get into later. And all I'm going to do is just run make. And what you see is it started the VM. And what it's now doing is it's using netcat to check if the port 22 for the SSH service is ready. And once it's ready, you can see there it's SSH'd into the VM. It's changed directory into the Podman directory, and it's run the start Invidious script, and the container has come up. So what I can now do is actually switch across to Invidious, and what you'll see is it's actually blank. And the reason for this is because by default what happens with Invidious is it only shows you videos that you have subscribed to. Now the issue with subscribing to lots of channels or playlists with Invidious is it actually slows it down, because what happens is it has to then scrape those channels from YouTube to actually update them. And the issue is that what can happen is once you've subscribed to a dozen or more channels, you can actually sort of get errors with it not pulling in the data. So what we're going to be doing instead is we're actually going to be using let me come across here. So I'm actually bookmarked Magpie channel here. So what we're going to be doing is, instead of subscribing to the channels inside Invidious, we're going to actually sort of just bookmark the channels. And what you can do is you can just drag this into the sidebar here in the bookmark sidebar to bookmark things. And what I'm going to do is actually show you the speed difference between using YouTube and Invidious to play the same video both in the browser and using MPV. Let me just drag this across here. What I'm going to do is actually play the first video, and this is from the Magpie channel TV. So we just wait here, experience interruptions.
Yes.
Okay, and it kicks in. Okay, so that should be kicking in. Why is it not playing? Let me just check the audio is actually working.
It's for Colaccini, so it's World Cup Day.
Okay, there we go. Yeah, I was just checking the audio is working. So that's the video playing in YouTube, okay? So you can see what happens is when you've got something like uBlock Origin installed, what will happen is you get a little experiencing delays thing there. Let me just come back out of this so it's not actually loading stuff up. So what I'm going to do is actually switch across to the bookmark version of the channel and play the same video in the browser with Invidious. Now, the other good thing about Invidious is there's no adverts, okay? And this is useful because what you can do is you can actually set Invidious to be available on the local network for other devices that can't do ad blocking, like your phone, your tablet, that sort of thing. What I'm going to do is just come in here and play this, and you can see here we've got exactly the same thing. I just press play.
Yes, people,
bang,
welcome back to the
straight away. Okay, no experiencing interruptions, none of that stuff. So play straight away. I'll just show you that again. So this is, it may have cached it on YouTube. Experiencing interruptions.
Yes, people.
And it kicks in, okay? Come back to this one.
Yes, people, welcome back to the
Just need it settled down a bit.
George Stevenson, where
it should be 1080. Yeah, there we go. It's on 1080. It's just sometimes when these things load up, it takes a second for it to stabilize. Okay, what I'm going to do now is actually show you another test, and that is playing the video with MPV. So what I'm going to do is actually, I need to actually set this to record the other screen. So what I'm going to do is actually grab the URL and come across to the desktop. And what I'm going to do is run time MPV, and let me just copy that out there. And so what this will do is this will actually show us how long it takes for the video to actually kick in. So what I'm going to do is press return here and then switch to the other monitor, and you'll see how long it takes to start playing the video from YouTube. And then what I'm going to do is actually show you playing the same video using MPV with Invidious. If I press return here, switch across to the monitor, and this is going to take about 5 or 6 seconds. Okay, there we go.
Welcome back to the Makefile.
That's actually kicked in. If I switch back here, we can see the how long it's actually taken to kick in. So what I want to do now is play the same video using MPV from Invidious. So time MPV, and what I'll do is, again, I'll switch back to the other monitor, and I'm just going to press return now. And you can see how much quicker that starts. Okay, I'll quit that, come back across here and show you the stats. So if we have a look at the stats here, so this is playing the video from YouTube. You can see total, the time here, okay, 6.57. Now the other interesting thing that I should mention is the CPU usage, because what we're actually going to be doing is we're going to be specifying to use VP9 codec with a Lua script for MPV. And what I found is playing the video directly from YouTube can actually have a CPU hit on MPV of like 80 to 100%. But when we're going to be using Invidious, that's going to drop down to about 10%. So this is actually the initial sort of spike when it starts up. But if you run top while this is actually active, you would actually see the difference. So again, this is the YouTube stats, 6.57, 80% CPU, 125 total. And this is the stats for Invidious. So we can see here 0.84 seconds, 22 CPU, 4.9 total. So the actual number we were looking for is the difference between the first one, 6.57 versus 0.84 of a second. So you can see that's how much quicker it kicked in. So let's just do the test again. So I'll switch back to the other monitor, press return now. Okay, 3, 4, 5, 6.
Yes,
It kicks in. Okay. What I'm going to do now is play the same video with Invidious. I'm going to press return now. 1.
Yes, people.
And see how much quicker that actually kicks in. So you can see the advantage there. What I'm going to do now is show you next thing we're going to be setting up. What I'm just going to do is basically show you what we're building and then take you through and actually build it. So I'm showing you the end result first, and then we'll start at the beginning, as it were. So we're going to the end of the book to find out who did it before reading the opening chapters, as it were. So what I'm going to do now is, instead of using Invidious directly and either subscribing to stuff or bookmarking things, what we're actually going to be doing is using YouTube, so that you've got all your subscriptions and everything on YouTube. And what we're going to do is we're going to copy the URL, okay? And I have a program called wlr-which-key, which is a WL roots sort of heads-up display that lets you execute scripts with a keyboard shortcut. And what I have is a emacs function that will actually rewrite the URL. So you can see here in the status bar at the bottom left, the actual URL is like youtube.com watch $v equals. And if you have a look down here, we have a similar URL but with HTTP and then my IP address, the port, and then watch. So what we're actually going to be doing is we're going to be rewriting the YouTube URLs, so that what it's going to do is it's actually then going to replace the youtube.com with the Invidious IP and port, so that it actually plays from Invidious instead of YouTube. And the advantage is, in Invidious, the URLs are already decoded. So with YouTube URLs, when you use MPV, it uses yt-dlp in the back end with deno to solve a JavaScript sort of challenge. And this takes about 5 or 6 seconds, as you could see in the time difference between playing the same video with MPV. So what I'm going to do is copy this URL, and what this is going to do, we're going to execute wlr-which-key, press the keyboard shortcut. It's going to rewrite the URL using Emacs. And additionally, what this allows us to do is, in Emacs, there is a mpv.el package. And we can use this with what's called a Hydra, which is a sort of like little heads-up display. And this will allow us to control MPV using Emacs. So what I'll do is I'll copy this. I will, you should be able to see here, what I'm going to do is press I for Invidious. I've got a keyboard, copy the URL, I'm going to press keyboard shortcut to bring this up, press I for Invidious, and then it will start playing on the other monitor. So what I'm going to do is actually switch across to the other monitor. Copy this, press I, and you should see this kicking straight away.
Welcome back to the Makefile channel.
Okay, and if I bring this up here, what you'll see is that it is 1920 by 1080. So again, I'm going to do the same thing with another video. Bang.
Alright everyone, welcome.
You see how quickly those pop up? So what I'm going to do now is I'm going to do the same thing, copy link. I'm going to use the M option, which just uses MPV. And as I said, what that's going to do is use yt-dlp and deno to solve the JavaScript challenge, which takes a couple of seconds. So what I'm going to do is copy that link. I'll switch back across to the monitor, and I'm running the script now. So 1, 2, 3, 4, 5, 6, 7. So about 7 or 8 seconds. Okay. And for comparison again, I'm going to do the same thing, but using the Invidious rewrite. So I'm going to press I for Invidious. So 1.
Yes, people, welcome back.
Okay, you can see the difference there. So I only managed to count to 1, whereas using MPV, I was getting up to 8. Okay, so you can instantly see the difference for this. And what I'll also do is I want to show you the CPU usage. So what I'll do is actually play a video with MPV, show you the CPU usage, and then compare that to the CPU usage that we are getting with Invidious. So what I'll do is I'll switch over here, run top, see OBS there. I'm going to copy this and wait for, you can see Python. So that's the JavaScript challenge, MPV, 110, 112.
A few Murphys.
Okay. Right. So that was playing a YouTube video with MPV. What I'm going to do now is come across, do the same thing and show you the Invidious CPU usage.
We're just here. The George Stevenson went
10%.
Celeste Ferdinand has his
8%.
a couple of weeks ago. I'm not
gone up again, but you can instantly see we've gone from 110% to 10% CPU usage. So we've got two benefits. We got the time it takes to load. So we've gone from 8 seconds to loading a video to under 1 second with MPV. And we've gone from a CPU usage of 110 to 117 down to about 10, fluctuating a bit, going from sort of like 8 to 10 to like 15, 17. So that is why using Invidious is a no-brainer, because as I said, it plays faster both in the browser, as I showed you, no experiencing delays and messages. There's no ads, so it's using less resources, and it also plays quicker using MPV, using the Lua script and the emacs rewrite code. What I'm going to do now is actually take you through setting up Bhyve and setting up Podman and installing Invidious. So, right, so Bhyve set up. So first of all, we're actually going to want to install some packages. I'm using DOAS in this, and the reason for this is DOAS allows you to create rules where you can specify a command that won't prompt you for a password, and we're actually going to be using this with the Makefile to actually start and stop the VM as I showed you. So what we're going to be doing is DOAS pkg install Bhyve firmware grub to Bhyve edk2 bhyve vm bhyve devel. So VM, there is a couple of ways you can actually create the Bhyve VMs. There is the more traditional method where you write out a long Bhyve command, but there is a sort of wrapper script called, was it Bhyve? Was it VM? Yeah, it's just basically called VM. And what this does is this actually simplifies using Bhyve, and it allows you to create a sort of the networking and use a template to create the VM. So again, the first step is we need to actually install all these packages that I've just listed. The next thing that we're actually going to be doing is creating ZFS datasets for the virtual machines. And what we're going to be doing is creating these in our home directory. So you need to change my username to your username here. And the reason why we're going to do this in our home directory as opposed to somewhere in the root file system is because it will actually make it easier for you to edit the files and save ISOs to the directories where Bhyve will actually look for them. So it's just personal preference. I prefer to have these kind of things in my home directory. And what it also means is what I do is I back up my home with ZFS send and receive to a USB drive, which I covered in a previous video. And this ensures that all my sort of setup is contained within the home and then successfully backed up. So what we're going to be doing is creating a dataset at zroot home your username VM, and that is going to correspond to this directory here. So this is a ZFS dataset that is mounted to VM in our home directory. So we're going to create the VM and then vm.iso, .templates, .config, and .img. What you then need to do is actually change the permissions on the VM directory. So doas chown -R your username username home your username VM. So again, that would be this directory here, which is, as I said, is a ZFS dataset. And because we're using doas with ZFS to create the dataset and mount it here, it would actually be owned by root. So that's why we need to change the permissions. So after we've done that, what we want to do is actually edit our etc.rc.conf. And what you can do is you can manually edit the file, or you can run the following commands. So doas sysrc kld_list plus equals vmm and nmdm, and the plus equals means append this to the KLD list. So if you were to run it without the plus, it would overwrite everything in your KLD list. By using plus equals, it will append these options to your KLD list. So etc rc.conf. Okay, so we've got ZFS enabled here. TF. So here you can see the KLD list, and I have an Nvidia graphics card, hence all the Nvidia stuff, Linux, Mac priorities for audio, and then you've got FuseFS, which is for EXT, mounting EXT stuff. And at the end, we've got VMM and NMDM. Okay, so you also want VM_enabled equals yes, and doas sysrc VM_directory equals ZFS:zroot VM. Okay, so have a look down here. I believe I've got that down the bottom. Yeah, okay, so there's the Bhyve settings. So actually, I need to change that while I think of it. So, my bad. Always good to double check these things. So, because that was the old setup I had. Okay. So what you would do here is you would change this, my username, to your username. So this corresponds to the data set we created up here. Let me just stage that. Okay. So again, you'd edit your rc.conf and KLD list. You would append VMM, NM, DM, and at the bottom we've got VM enabled equals yes. The VM directory equals ZFS zroot home, your username VM, and then gateway enabled equals yes, and that is for networking. Let's click that. So when you first set this up, if you haven't rebooted, what you can do is run doas kld load vmm nmdm, and that will load the modules that we've added to our KLD list so that you don't actually have to reboot after applying them. And that's another nice feature of Freebsd, is not needing to reboot so much as a sort of Linux when you've made changes like this. Okay, so the networking, we set the gateway enabled equals yes. What you also need is in your sysctl, etc. sysctl.conf. You can see down here at the bottom, what we have is netlink tap up on open and net init IP forwarding equals 1. Okay, so those are there, so you can manually edit your sysctl.conf. I think from memory, can't remember offhand if this just temporarily sets them or sets them permanently. Have to double check on that. Okay. So the next thing that we're actually going to do is copy the Bhyve templates. And yeah, so what we're going to be doing is actually copying all of the templates from this location. Okay, you can see here there are lots of templates that you can use to create virtual machines. And what we're going to be doing is copying them into, again, my bad. What helps to go through these things. So what we're going to be doing is copying into home your username vm.templates. Push as I go along. Okay. So what happened was I was basically using another setup where the by default it will, the instructions for this kind of thing will actually tell you to use a dataset at VM. So the path, the directory would be like VM templates, whereas as I said, I prefer to have this stored in my home directory because it makes it easier to actually edit the files and back things up. So we copy the Bhyve config files, the templates from this location to our home username vm.templates directory. So VM, And what you see is this is blank. If I show hidden files, go to templates, you will see all the templates. And what we're going to be doing is creating a new template here that will take you through to actually set up Ubuntu, because there are a couple of gotchas that took me a while to actually figure out. There was an issue of starting the virtual machine, it not finding EFI or grub, and I'll show you the secret fix for that. So what we're going to be doing, as I said, is we're going to be using doas. So what you can do is install doas, and what you can then do is actually create a rule for the VM command. So if I come across to user local etc doas.conf, now what I have actually got set up is I have doas set up so it doesn't prompt me for my password for any commands, and this is especially handy for if you're writing scripts to automate things that require admin privileges, or also using emacs with tramp to edit files. It doesn't prompt you for a password. So what we got up here is, first of all, permit user, keep environment, set environment path, your username. What we then have is allow root to switch to our user. So this allows root to, and say, switch to our user. So we have permit no pass, keep environment, set environment path, root as your username. And then what we have is permit user no pass. So what this line does, if I zoom in once more, permit no pass, keep environment, set environment path, username. This means that I can run any command that requires admin privileges using doas and not be prompted for a password. So I don't actually have because I have this, I haven't actually got this command listed in my doas.conf because I've got it set so I can run any command. But what you can also do is, if you don't want to do that, what you can do is you can actually create rules for specific applications or programs that require admin privileges, and you can set them so that they don't require you to enter a password. So what you would see here is permit no pass, my username command VM, and what you would do is you would actually add this, so you'd have these sections up at the top, and then underneath that you would then put those kind of commands. So you can see here, for example, permit no pass, keep environment command, and you can put in the full path to the command, which sometimes you need to do. But at the bottom, what we have is root as root, permit no pass, keep environment root as root, and that is so that root can properly switch. When it's actually switching, it switches properly as root. And you need the commands in this particular order. The order does actually matter. So that's the doas. Okay. Let's just now onto the service VM start. So what we're going to do is run doas service VM start. Okay. I think the first time you do this, what you need to do is run doas VM init. And what we've got here is, this is how you can create the networking. So what you see, if I come across to if config, what you see, I've got tap 0 lago VM public. So what this does is this creates the networking. So what we've got here is we're creating a public VM public, and what you can see here is this lago. This is my combined virtual interface that I covered in a previous video, where you can create a fallback virtual network interface that combines the Ethernet and Wi-Fi, so that when you unplug the Ethernet, it automatically switches to Wi-Fi, and when you plug the Ethernet back in, it switches back to Ethernet. And this is particularly useful for PF configuration, because what it allows you to do in your PF configuration, if I switch across to my PF configuration, etc., pf.conf, what you'll see up here is interface if lago, and what happens is typically in your pf.conf, what you have to do is specify the network interface. And so if you're on Ethernet, you would have your Ethernet interface in here. And then if you switch to Wi-Fi, you'd have to stop PF configuration, change the interface to your Wi-Fi interface and restart it. And then when you switched back, you'd have to do the reverse. And so by having this Lago failback interface, it means you don't have to alter your PF configuration depending whether you're on Ethernet or Wi-Fi. So I'll put a link to all this stuff, all my configuration files. And what happens is these commands actually create this, but what I found was I kept having to run this last command manually. Config vm public add lago, but us local etc rc.d lag pf. So in my user local etc rc.d, I have a file here called lag.pf, and what this does is this actually restarts lag, it restarts pf, and what it does at the end is it automatically runs that last command, if config vm public add lago. And so once this is actually set up, and I'll give you links to all my root.files, it means that the once you've actually added these and got that lag.pf file set up, you don't have to do it again. This is just a one-time thing to actually create the networking. Okay, so we're now onto the Bhyve VM create. So first of all, what we're going to do is actually fetch an ISO. Now, there is actually a helper function built into the VM script to actually fetch an ISO from a URL, but what I found was it would actually time out. So I found, in my experience, it's actually better to use fetch, which is the built-in command with Freebsd to fetch things. And what we're doing here is running fetch-o and the path to where we want the file to be saved. So home username vm.iso, which is again that data set that we created in our home directory for the ISOs. And what we'll be doing is downloading Ubuntu 26.04. And what that will do is that will actually, I'll have to put a link to that Lego thing in, VM ISO. And what that will do is that will save that ISO file into this directory. And because it's actually stored in that directory, the template file that we're going to use will automatically pick it up. So what we're going to do is we're going to find the number of CPUs that we have, running sysctl kern.shed topology spec. Oops. And that's going to spit out a load of stuff. But basically, the long and short of it is you can actually work out from that command how many CPUs you've got, which you can then use in the template. What we've got now here is the actual template file. So again, this is installed and I need to change that. Oops. Templates. It does help me make sure my notes are correct so that when you actually go there, you know, nothing worse than having bad documentation. Let's just fill the tea up. Right, so we don't need the DOAS either. Just check the permissions on these. Yeah. So again, you may need to, I don't think you need to change the permissions on the templates file. Templates. And this is magic. Okay. So this is the ubuntu.conf template. So what we're going to be doing is we're going to be using UEFI. Now, in recent changes to some distros, what happened was the old way I was doing this with Grub stopped working, and for the life of me, I couldn't figure it out. It would just give me these 4H or 8H errors. Couldn't find Grub, and I switched to UEFI, and I think it may have been Scrotto and Vermarden on the FreeBSD forums came up with some sort of different workarounds to actually fix this, which were a bit convoluted and required booting in and creating a directory and copying a UEFI, a boot file and renaming it, all this kind of stuff. But what I found, the actual fix, I'll get onto. So we've got the loader UEFI, the CPU, the memory, the network type, virtio net, the network switch public, and that should correspond. You can see here VM public. That corresponds to that. So this is where we've actually got the settings. This is the one you need. Disk 0 _ type equals NVMe. And this solves, I haven't tried this with Grub, but as I said, you probably want to be using UEFI, which will additionally allow you to connect with a VNC client. So that's the first thing. Disk 0 type NVMe, disco name equals disco, and what you've got here is the dev, and what I have this set to is sparse Z volume, and this is a sparse image that actually grows as it sort of fills up. However, if I come across to Vermarden's notes on Bhyve from a couple of years ago, he had some interesting observations about using a raw file versus a ZFS Z volume device. And you can actually see that using a raw file, which you'd create with something like truncate, so you can go, you can use the truncate command to actually create a disk image with a set size of like 60 gig or something. There is actually a considerable performance boost using a raw file instead of a ZFS Z volume. However, I'd already got this set up and I couldn't be asked to take it down just to use the raw file. I haven't really found it an issue with the setup I'm using, but that's just something to bear in mind. There's a bit of a sort of trade-off, as I said, with a disk image, you're creating a file with a set size, like say 60 gig or whatever. I believe it's possible to change the size of the file afterwards in case you're running out of space in the VM, but a sparse volume actually grows as needed, I believe. So it's kind of a bit of a trade-off. As I said, it may depend on what you're actually running in the VM, whether that sort of performance boost is actually going to be of any negligible difference to you. So that's the this is the template for Ubuntu. And again, the important thing to remember is you need this NVMe, and that solves the issue with the the VM not being able to find the UEFI partition to boot from. What we've got down here is the last bit of the setup. The important thing we've got down here is graphics, yes, mouse, yes, graphics resolution, and UEFI vars. And what this will allow you to do is actually use a VNC client to connect to the VM as well, which can be helpful during the setup, because what I found was there was a way I was using previously with Grub where you'd use the VM console, but that kept failing. But when you actually set this up, you can either do it using VNC or actually in the terminal. So this just kind of gives you a bit more flexibility. So that's the template. Okay. And then what we do is as VM create type, so this is going to be the name, Ubuntu S60 gig Ubuntu, and that's going to correspond to the name of the template it uses. Okay, so you can see ubuntu.conf there. So that's how it picks up the template that we're actually using. So what we then do is we actually run, so we've actually created it, but then we need to install it. So we run as vm install -f ubuntu, and then the actual name of the ISO that is stored again in the vm.iso directory dataset. You can see there. Yeah. So that will actually create the VM, and what will happen is when you run this in the terminal, it will go through and it will then dump you to the installer. Now, if you want to use a VNC client on Wayland, what you can install is wlr-which-key, and this is a very lightweight VNC client. If you're using something like X11, I think you can use something like Tiger VNC. But this is the actual format for the VNC connection. So the VNC port, if I come back to the vm.templates, Ubuntu, you can see at the bottom, where was it? Does it specify it? No, but I think basically when you set graphics up, it's going to expect the it will expose that port. So for WLV-NCC, the format is WLV-NCC-F, and that's actually sort of software encoding, because I had a problem without that. And then the address is 127.0.0.15900, and that will give you access with the VNC client. So the next step is actually setting up Podman. Just finished the tea off. Let me just check I've got my notes. Oh yeah, I've got my SSH notes in there. So as I said, when you run the VM create command, the VM install command rather, okay, the F option actually causes it to run in the current terminal, so you will actually get the installer come up in the terminal. You go through and do all the settings. Can't think offhand if there was any settings you actually had to apply. I didn't. There's not really any point in applying LVM encryption for a VM, to be honest. But to install Podman, so you've set up the VM, you've logged in, you created your account and everything. You've done a sudo app update and upgrade just to make sure And then what we're going to do is sudo apt install git podman -compose and pwgen, which is used to create passwords. So sudo apt install git podman -compose and pwgen. What we then need to do is actually edit the etc containers registry.conf by running sudo vi etc containers registry.conf. And at the bottom of the file, what you want to do is put this little section here, registries.search registries equals docker.io and qa.io. And what this means is that when you run Podman, it will automatically know to look in those repositories to pull down the images from. So save and quit that with, I'm sure you know how to use VI if you're using FreeBSD, but you know, escape control :WQ. What we then need to do is actually edit this file called userbin pasta. So sudo vi etc aparma.d user.bin.pasta, and you want to add the following code: signal receive set equals term peer equals podman, and the file should look like this. So you can see up at the top here, got this section include, and then just under that, what we're going to be doing is add the signal receive set equals term p equals podman, comma, and what that does is prevent an error when you're actually stopping the podman container, because aparma will otherwise give you sort of error messages, and that bit of code prevents it. So that's the aparma. What we also need to do is, once we're logged into the server, what you want to do is, as your regular user, run login ctl enable -linger and then your username. And this is required so that what we're going to be doing is, instead of every time we want to start up the container, instead of running doas vm start ubuntu, waiting for a minute, then SSHing into the VM, changing directory into the Podman container and starting up the Podman container, we're going to be using a Makefile to automate the process and also bring the container and the VM down. And what happens is, with that particular setup, if you're running, because you're kind of doing a one-shot command and not staying logged in, the service wouldn't stay active. So what this login ctl enable linger command does is, when you're doing that, it will keep the service running, so that it doesn't shut down. Okay, so the next step is in the let me just do this. Okay, there we go. So I'm here inside the VM, and you can see by default it's put me in the home directory. So what we're going to be doing is actually creating a directory called Podman, and inside there we're going to be creating another directory called Invidious-Podman, and we're going to be cloning the Invidious repository into there, as you can see. And so we're calling this Invidious.podman, because otherwise it'd be, the file path would be podman invidious/invidious, and it's kind of not clear which directory you're in, especially for writing notes. It would get confusing. So what we need to do is clone the directory. So make directory we're going to create the Podman directory in your home. Change directory into the Podman directory. Yeah, let's set up. So going through the notes, actually, it does help me pick up any, not so much errors, but more things I've kind of missed out, you know. So we create the Podman directory here, mkdir-p Podman, and then we change directory into it, so cd Podman, and then we create the Invidious Podman directory. Okay, we've got the Invidious Podman directory, then we cd into that. And what you then need to do is actually clone the Invidious Git repository by running git clone and the path to the Invidious.git repository. Now, at the time of the recording, there is actually a issue with Invidious not displaying channels. So if I come across here, what you'll see is I'm in the channel here and it's showing all the thumbnails. And with the current version of Invidious that you can pull from the Docker.io or QA.io images, there is a bug where it will actually show you something like unable to retrieve image or something on all of these, so it won't actually show you the images. So normally what you would do is if the fix has been applied to the image in the future, what you would do is you would use this compose.yaml file. So what you'll see here is I've got that's a backup, compose.yaml, and I've got the Invidious directory, and I've got a script called start Invidious, which actually starts the container and exports some secret keys that are needed to start up Invidious. So in the future, hopefully when this is fixed, you would use this compose.yaml, and what you can see here, it says image QAIO Invidious latest. But at present, what you need to do is apply this channel fix. So we've got the Invidious Git repository here. What you do is you change directory into that. And what you'll do is you'll download this patch. So you'll run git fetch origin pull /5736 /head : channel -fix. Then what you're going to do is you're actually going to run git checkout channel -fix. And what this is doing is it's actually creating a separate branch with the channel fix so that the images show up in the channels. And what we've got here is the compose.yaml file. And what you'll see here is I've commented out this section here, image QAIO Invidious. And underneath what I have is image : my patched Invidious. And what we're going to be doing, that's the only change between the two compose.yaml files. And so what we're going to be doing is we're actually going to be building Invidious with the channel fix. So remember the steps. We've changed into the Invidious directory. We've run git fetch origin pull in the channel fix. We've checked out that branch. We have the compose.yaml file. So the other thing is I'll come up here, the compose.yaml file is actually stored outside of the Invidious Git repository. Okay, and we're going to build the image inside the Git repository, but you can see here we've got this start Invidious script, and this works with the compose.yaml file. And the reason these are kept outside of the Git repository is so that you can do a git pull and not have untracked files. So again, we'd be in the Invidious Git repository. We'd have pulled everything down, and what we're going to do is run Podman build -t my patched Invidious --build args release equals true f docker file from docker io crystal lang crystal alpine dot. And what this is going to do is actually going to build the image locally, which may take about 10 to 15 minutes depending on your setup. And again, this is just needed at the time of recording to fix this particular bug. And normally you can pull directly from the AI repository and it will just pull everything down. But at the moment, we need this channel fix, get all the images showing up in the channels. So once that's actually built, what you can do is we have, if I come back out here, you'll see we got this start Invidious script. So we'd create the script to make sure it's executable. And what you'll see here in the script is we're using pwgen, which we installed with apt. And what we have to do is create a secret companion key and a secret hammock key. And what we then do is we're actually setting these variables here, which are actually used in the compose.yaml file. So rather than actually hard coding the passwords in the compose.yaml file, which would mean you couldn't push it up to GitHub, we've got this script that will dynamically create these keys that are required for Invidious every time we run this startup script. And at the end, what it will do is it run podman-compose up d, detach. Okay. So once we've got that set up, what we can do is we can just run start Invidious. Okay. So that would start up Invidious and get it set up. So when you're in, what you need to do is you need to actually run IPA. And what you see here is the IP address of the VM 192.168.1236. And what you would then do is open your browser to the address there. So you can see this is that with :3000. Okay, :3000. Now, when you first come up into Invidious, it will have a little login button here. And you click the login button, then it will prompt you to enter a username and a password. And then what will happen is it will actually give you a captcha. So what it's actually going to do is actually it will show you an analog clock with hours, minutes, and seconds. And underneath it will have a little text field with 00:00:00. And what you have to do is put in the hours, minutes, and seconds as shown in the analog clock into the captcha. So, for example, if the time in the captcha was, say, 09, 15, 20, so 9, 15, and 20 seconds, hours, minutes, seconds, that is what you would have to put in the captcha. Hope that makes sense, but that had me baffled for quite a while when I first set it up. Okay. Close some of these down. Okay, so you got all this set up. So suppose you're starting from scratch and you want to start the VM. And we come exit. Okay, come into here and I'll do make clean. I'll show you this script. Okay, so if we wanted to do this manually, what we'd do is run doas VM start Ubuntu. Okay, and that's starting the VM. You would then SSH into it, and what I'll do is I'll show you the tip for setting up SSH, where you can actually copy your SSH keys to the VM so that you can basically enter the VM without any password. So if I do, okay, I'm now in the VM. Let's see if I can show you SSH. I think that's, yeah, so in my config, let me just copy this section. So in my config, my SSH config, I have the host name, which are called Loki, username, the port, and the IP address. What that means is I can just run SSH Loki and it will put me inside the VM as shown here. And so if I wanted to, so I've done doas VM start Ubuntu, I've SSH'd into the machine, and then to do this manually, what I do is cd Podman, cd Podman Invidious, and then I'd run start Invidious, and that would export the keys and use Podman compose up -d to start the container. Okay, that's too long. There's a better way. So you can stop you can stop the VM, the Invidious, by running doas Podman compose down. This is how you would normally update the Invidious if you're pulling from images, but again, at the moment we're having to do this channel fix, but these are just the notes. So this is how you can stop the VM or destroy the VM. A couple of methods there. Again, start, stop, and this is how you can copy your SSH keys to the VM. And what will happen is you'll be prompted for the password. So you do SSH copy, SSH-copy-ID, your username in the VM and then the IP address of the VM, and it would then prompt you for the password for the user in the VM. And once you've done that, you'll be able to SSH in. And again, what you would normally do is SSH username and like this, but by creating a SSH config, you can shorten that to SSH and then the host name. Okay. So, and this is how you remove sort of all containers, which I'll just leave there as notes. What I'm going to do now is take you through the Makefile. So, make Invidious Makefile. So the Makefiles are all called. I've got another one here for start with CRXNG with Podman. But what I've done is create a ZFS data set in my home called Make, as you can see here. And in there, what I have is different directories. And the reason why you want different directories is because all the files are going to be called Makefile. So what we have here is the way that we can we'll just bring that down to the make theme, make just short. Okay, I'd already stopped that or started. So what we've got here is no more T. What we've got here is a Makefile. So I said, instead of us running doas VM start Ubuntu, waiting for it to start up and then SSHing into it and then changing directory into the Podman container and then running the script, why not automate those steps? So first I was thinking, oh, well, you could do a script for that. So essentially what we're wanting to do is execute a series of commands one after another when they have completed. And that's what a Makefile does. So a Makefile has the ability to run sort of two commands. You can run make and then make clean. So then I got to thinking, okay, so we can run make and have all the commands executed to start the VM, SSH into it, run the script and start Podman. But wouldn't it be nice if we could do the reverse and actually SSH into the machine, stop the Podman container, exit, and then stop the VM? And that's what we're going to be doing with make clean. So what we have here is a file, Makefile, project Invidious, and this is a header to help you so you know instantly which file you're working on. Then what we have here is phony, and what this means is that it says that these aren't real commands. So like clean is not an actual command you'd run on the command line, it's a variable inside the Makefile. Okay, so what we have here are a series of commands that we're actually going to be using. So we've got the VM name, Ubuntu, we've got VM start, we've got stop, and what we have here is the server. So we've got the server IP and the port, and again this is the host name defined in our ssh.config. What we then have is the remote directory, which is podman invidious-podman, and that's the location of the script. Then we've got podman start, and that corresponds to the name of the script we're going to be running. Then we've got podman stop, and this is podman compose down. So what we've got down here is we've got remote start, remote stop. So what this does is cd remote directory, so it changes into this directory, and then it runs podman start to run the start script. Then we've got podman stop, and that runs podman compose down. What we have now here is the default target. So we've got all and then SSH, and this is the final command that we're going to be running. So what we've got here is this all basically is all of these steps that are going to be executed in the Makefile. And what we have here, first of all, is start the VM. We've got VM, doas, VM start, VM name. So VM start, okay, that's start, and then VM name. So what this basically translates into is doas VM start Ubuntu. Yeah, so that is the same command we'd be running on the command line. Then what we have is netcat. So what you see here is netcat and then VM. So what this means is this step here requires this VM step to be completed first. So what we're doing is we're actually using netcat, and we've got this little until loop. So what we're doing is we're actually checking the server IP and the port that was defined up above. And what we see is guest OS booting up, waiting for SSH, and sleep 1. So what it's doing is it's checking if port 22, the SSH port, is open, right? So rather than just doing something like sleep 10 or sleep 20, what we can actually do is we start the VM up and we run netcat. It checks whether port 22 is open. Then what we're doing is we see this SSH command, and that depends on netcat. So this command only executes when this command has finished. So once the port is open, it's then going to run SSH server and then remote start. So SSH server, the server is defined up here. That's the host name, find in the shush config. And then we got remote start. What this does is remote starts CDs into the remote directory, CDs into Podman, Invidious Podman, and then you can see colon, so that's the first command. So it changes into this directory, and then it runs the start Invidious script that exports the variables and then runs Podman doas compose up. Yeah. So it then starts the it waits till netcat's finished and it SSHs into the server and changes into the directory and starts up the script. Then what we have down at the bottom is clean. So SSH server remote stop. So what that does is that SSHs into the server, then it runs remote stop. And what that does is run cd remote directory, Podman Invidious, and then Podman stop. And once it's in that directory, it runs Podman compose down. Then what it does is runs doas VM stop VM name. So VM stop is stop, and the VM name is Ubuntu. And the reason why we're doing all this with variables is because what this means is that you can actually reuse this script and just change the server name and port and the commands that you actually want to execute. So when we run make clean, it SSHs into the server, stops Podman, and then once it's done that, it stops the VM. So we're in here. So rather than me doing this manually, as I said, doas VM start Ubuntu, twiddle my thumbs. I don't know if the SSH has started up, the port is open yet. SSHing in, changing directory and running the script. I just run make, starting the VM, probing port 22, waiting for SSH. So this is using netcat, seeing if the port's open. SSHing in, running the script, bringing up Podman. Bang. So now Invidious has started, and if I come across here, go to my channel. Sometimes it takes a second because what it's doing is it's actually pulling down the images. So sometimes, there we go. So there you go, you can see my channel. 100 off 4,000. I don't think you get any plaques for 4,000. So that's how we can start the container. And again, when we want to stop it, we just run make clean. And what it will then do is it will do the reverse. It will SSH in, bring down the Podman container and stop the VM. So what we're going to do now is take you through some of the additional setup I showed you, where we have we've got a couple of things. We've got, first of all, we have the config wlr-which-key. So what this is wlr-which-key. You can see I press a keyboard shortcut and I have a series of keys I can press with a name describing them, and those will actually execute scripts. So this is a really handy way of actually having a heads-up display that you can use to run scripts. If I zoom in, what you'll see, again, wlr-which-key is a WL root-based application. So it won't work on GNOME or KDE, but you might be running KDE on Freebsd. I know some people do, and I really don't know why, because it's awful. That's just my opinion. I always found it really bloated, bad desktop. But this is how we can theme wlr-which-key. We've got it centered so it comes up in the center. You can have it pop up in different places. And this is where we define the menu. What you see is it's a YAML file. So we've got key, the description, and then the command. So the command that is actually going to be running is a emacs function, and what this will do is it will rewrite the URLs from YouTube to Invidious URLs, and then use mpv.el to play the video with MPV. And what you can then do is actually control it with a Hydra. So we've got two commands here. We've got the one for Invidious, and then we've got the one for MPV. So if I come into my, what I need to do actually also is show you MPV. So this is the MPV directory.config/MPV. And what you see is I've got two files and a directory. So if we come into the input, this is the input which controls the keyboard shortcuts and bindings within MPV. So what I've got set up here is Vim key bindings. So HJ, L, H, J, K, and J. So if I press L on the keyboard, it goes forward 5 seconds, H it goes back 5 seconds, K seeks forward, and J seeks backwards. And we've got subtitle cycle, rotate, and what we've got here is audio filters. So if you press F1 on the keyboard, it will come up this a heads-up display in MPV, and then you can press F2, F3, F4, or F5, and these correspond to these commands down here, where it's actually FFmpeg filters that will either use loud norm, dynamic audio normal, low bass or low treble, to actually alter the audio filter being applied to the video. And so this is particularly useful if you've got video that's quite low. You can press F2 and get it to run a loud norm filter, or dynamic audio, or lower bass or lower treble. That's the input.conf. And then in the mpv.conf, okay, let's go through that. What we have here is what are called conditional profiles. So with MPV, what you can do is actually create profiles that only apply to video streams with a particular URL, whether it's a domain or an IP. So what we have up at the top is profile HW decode. So this is the default profile. And what you see here is we've got VO, GPU, GPU context Wayland, and HW decode VAPI. And we've got the message level here. So what this does is message level equals FFmpeg equals fatal. And what that does is if you're on the command line running MPV, it will suppress all sort of FFmpeg errors and give you a clean output. We got cache no, and we got the yt-dlp format, best video, height equals 1080p, and best audio. And so what this does is I don't want to play 4K videos with MPV, they just take too long to sort of buffer up. So this basically means that the master profile is set just to play 1080p or less. We've got OSD fractions, which actually shows fractions of a second in the on-screen display. YouTube subtitles, so this is useful for displaying YouTube subtitles. So we've got subauto fuzzy, yt-dlp, raw options, sub language, English, right sub, right auto sub, and sub font, Noto color emoji. So you want to have the Noto color emoji font installed, and you've got to be careful with the Noto fonts, because there are some which, if you install the meta package, it will install about 2 gig of stuff. But you need the emoji font, because some YouTube video titles have emojis in them, and without that you kind of get a broken symbol. We got the screenshot template, so this is the format of the screenshot template with MPV, which I believe from memory will actually save it with the file name and like the time appended from where you took the screenshot. Then these are the conditional profiles. So what you can actually do is you can, on the command line, you can specify mpv -- profile equals and then the name of a profile. But these are actually automatic. So what we've got here, for instance, this is the automatic conditional profile match any YouTube URLs. So you can see brackets YouTube profile description, and we have this profile condition equals path find YouTube, okay, and then nil. And what this does is this finds both, you kind of get the YouTube, you get youtube.com, but then there's that other weird URL, and this basically matches both those URLs, and it includes the hardware decoding profile, but we can then override settings like we can set cache to yes, and we can set it to be full screen and full screen on our second display. And so this is the Invidious conditional profile, which is basically the same as the YouTube one, except what we're doing here is putting in the actual IP and port that Invidious is running on. Okay, and so what happens is this will apply to all URLs for Invidious. So the next thing that we have here is this Lua script, this Invidious.Lua script. And basically, as I said, Invidious will decode the URLs in the browser to actually give you the direct link to the audio and video streams. Whereas if you're using YouTube and you use MPV, it has to use yt-dlp in the back end to do that. So the way that the streams work with Invidious is they have what's called an MPD file, and that is a text file that actually contains a list of the different streams and their resolutions from like 4K down to 1080, 720, etc. So what I did was I did some digging around and actually found the location of the MPD file. And what I did was actually get Gemini to create this Lua script that will actually take when you go to a video, for example, one of these, what it will do is this only applies to the Invidious URLs. So you can see here you would need to change the IP. You don't need to change the port, but you need to change the IP here everywhere it's listed. And basically what this does is this intercept when MPV plays a Invidious URL, it will bypass using yt-dlp completely and get the MPD manifest file and search through the file using both curl and JQ, which you'll need installed, and it will get the title of the video, and any video you'll find streams from 1080p downwards. So I've specifically set it to not fetch 4K videos because I said they just take too long to buffer up. So what this Invidious.Lua script does, as I said, it will do the equivalent of yt-dlp in that it will get the streams and it will get the title, except it takes less than 1 second playing the video with MPV and this Lua script, as opposed to playing a YouTube URL with MPV and yt-dlp, which you could see took up to 8 seconds, because what it has to do is it's got to fire up Python, it's then got to load up deno. It's then got to solve the JavaScript challenge, and then it will get the URLs, and then it will pass those URLs onto MPV. And that's why when you play a YouTube video with MPV, it takes so long to actually load up. And that's what this Lua script does, basically. And additionally, what it does is it looks for it looks for sort of different versions of codecs, sort of like VP9. And as I said, the other advantage of this setup is that the not only the time it takes for the video to kick in, less than a second versus 8 seconds, but the CPU usage. As I said, I showed you when we were playing a video with MPV from YouTube, the CPU usage was going up to like 117%, and then settling down about 100%, whereas using the MPV setup with the Lua script, the CPU usage was like going from 8 to 10 and then peaking at 17%. So we've locked up like literally 100% off the CPU usage when playing a 1080p video from Invidious versus YouTube. So what I'm going to do now is actually take you through my mpv.el setup. So this is using use package, and mpv.el is a package that works with Emacs and allows you to control MPV using Emacs using a Hydra. So what I've got here is what's called a Hydra. So I can press a keyboard shortcut, which I've got bound to Control A, and what you'll see here is we have Seek, Actions, General, and Playlist. So what we've got here is, as I showed you, these are the keys to seek forward and backwards, H, J, K, and L, seek forwards and backwards. And we've got actions here to step forward and backwards the frame with comma and period, pause for space, Q for quit. These ones are used to insert the playback position into an org file. So what you can actually do is you can actually have timestamps in an org file, and I've got a keyboard shortcut. And when I press that, it will jump to that timestamp in the video. And this is to insert a new line. When I do it, I can take a screenshot, show the OSD, and I've got playlists here. So I've also got a function set up so that when you play a video, or when I bring up this heads up display. So if I copy a URL from YouTube and run the keyboard shortcut, press I, it sends it to Invidious. If I do the same thing again on another video, what it'll do is it'll actually queue it up into a playlist. And what these functions allow us to do is actually jump to the next item in the playlist, previous items, show the jump to an item, a particular item in the playlist, or remove a playlist entry. So I have functions in, let me just come back up here, MPV, the first one. Yeah, so this one here, key map set global map, control X, comma, MPV seek to position at point. And they said what that allows you to do is you can have an org file with timestamps, as I showed you, control, oops. If I do insert playback position, what it will do is it will insert the playback position. I usually do it in a example code block. Then you can have your keyboard, then you can have the mouse, the cursor over that timestamp and run Control X, comma, and it will jump to that point in the video. And that is particularly useful to use with subtitles files. So what you can do is you can actually have a subtitles file open for the video, and you can then search through the subtitles file for a particular phrase. So for example, if I was kind of watching this video, suppose I had this video downloaded locally with a subtitles file, and I wanted to jump to the bit where he says Steve Nixon, what I can do is I can run, Control S, search for the line, search for the Steve Nixon, and position my cursor over the timestamp, and then run Control X, comma, and then jump to that point in the video. So it's particularly useful to use with subtitle files. But let's get on to and I've got diode here. So I've got a keyboard shortcut for diode so that video OBS, when I'm in one of these, this is a load of videos, I can just press L and it will automatically open the video with MPV. Well, let's get on to the MPV package setup. So use package MPV. We've got set Q MPV default options. And what we're doing here is -FS for full screen and the name of the full screen device. So my second monitor is DP-3. What I have here is a function that lets me create a video link. So when you do Control C, Control L, is it Control C? What was it? There's a keyboard shortcut, I forget off the top of my head. When you can insert a link to a file. What this does is this actually creates a link. So you can have, normally you'd have a link that's, like /http example.com example, like that would be a sort of link. What this function does is it prefixes video to the link. Let me see if I've actually what you can do is, so this opens this is a regular link, and I've got one that's, the YouTube. So if you specify EWW, it will open this with EWW. But what I've got is I can't remember if I've got it anywhere in this file, but what it does is it creates a video link handler so that you can create org mode links that will automatically open the link in MPV. I just can't remember what the keyboard shortcut is for that. But what we've got here is, first of all, a function. And what this does is this basically checks if MPV is running. If it's not, what it does is it runs MPV start URL and it plays the current video from the clipboard. But if it's not running, if it is running, what it will do is it will actually append that URL and create a playlist. And this isn't a physical playlist file. It's just a sort of temporary sort of file that gets created. And as I said, that will work with the Hydra so that you can actually queue up videos to play. And the nice feature of that is the videos will be played sequentially one after the other without the MPV window closing. So this is the master command that either plays a video or queues it up if one's playing. Then what we have down here is we've got a couple of functions. So we got MPV play remote, MPV play clipboard, which is used to play the video from the clipboard. It basically gets the current URL on the clipboard, and we've got one for EWW here. But this is the function that actually rewrites the URL. So, as I said, rather than me actually being in Invidious, I can be on YouTube, copy the URL, run wlr-which-key, press I, that runs Invidious and it then calls this function, and what it does is it gets the URL and it replaces youtube.com with the Invidious domain instead, okay? And then it actually will actually play it. It runs this function down here, which is the one up here. So that's how we can copy the URL from the clipboard, rewrite it, and then play it. And additionally, what happens is there's a Doom mode line now playing, which will actually display the video playing. So if I just come across and do that, and you can see here, watch. Okay, give it a second.
Yes, people.
And what you can see here, if I pause that, is we have the time, the current time, the length of the video, and I've got it set so that it actually truncates the text so that it doesn't kind of push everything along. But now that this is open, what I can do is I can run Control A, and what you'll see here is I've now got the Hydra come up, and I can press space. I can go backwards, back to the beginning, forwards, backwards, all from within Emacs, and then press Q to quit it, and then escape to close that. So that's the Hydra. So I'll get onto the Hydra. We've got the files, links and hooks. Yeah, and so these are all settings. This is used with the dyad setup, so that what it does is the dyad function checks if what the MIME type of the file under the cursor is, so it doesn't try and play a text file with MPV. It checks the actual supported MIME types before it tries to play it. And these are the functions here that are actually from the Hydra. Okay, insert playback position, and then if I come down to the Hydra, what you see is use package Hydra after MPV, and this is what the Hydra looks like. So this is how you define the Hydra, and you can see seek actions general, and that corresponds to this. So seek actions general playlists, that's how you get the header and then the line, and then these are the items underneath it, and these are the commands that are actually going to be run. So these are the keyboard shortcuts and the functions that actually get run. Okay, so that's the gist of it. I know it took a while to get through. These things usually do when they're sort of overly complex. But the upshot is, as I said, once I've got all this set up, I can easily start this Invidious up just by running make. When I want to stop it, I just run make clean. That then starts up Invidious. And I don't even need to be on Invidious to use it. I can be on YouTube. And as I said, what I can then do is just copy the URL. Let's switch this back across here. So again, show you the speed of this. Okay, press I on the keyboard. 1. I didn't even get to count to 1. Okay, you can see. So that's how quick it is. Let me come across to Adam P. Okay, I'm going to do the same thing with another video. I'm pressing I now. So 1, 2.
Come on, guys, it's Adam.
Okay, right. I'm going to do the same video now using Let's actually let me show you the CPU usage again. So what I'll do is I'll come back across here, run top, and what I'll do is just close that. So I'll play this with what I'll do, actually, I'll show you how long it takes to come up on the screen, and then I'll switch back and show you the CPU usage. So I'll switch across, copy the link, and pressing M now. So 1, 2, 3, 4, 5.
What's going on, guys?
Okay, 5 seconds roughly. And what I'm going to do is come across here,
We've got a lot
and
of information in the past
where's
hour, so we now
I'll do the right one.
I
I can't remember if I actually clicked the right one. Hang on. I think I might have clicked the wrong one. Hang on. So 1, 2, 3, 4, 5.
What's going on, guys? It's Adam.
Okay, we can see MPV. There's MPV. It's coming up here. Sometimes it depends on the actual video that's actually being played. So let me just try it with that video that Matty did that seemed to have a higher CPU usage. You can see Python kicking in there. Still Python. Now it's opened. 100%, 92. Okay. Now what I'm going to do is I'm going to do the same thing. Oh, sorry. I wasn't actually showing you the CPU usage there. My bad. Okay. Let me just do that again. Okay. Copy link. M. Python. It's not opened yet. Now it's opened. Now it's gone up to 109%, 97. Okay. Now I'm going to do the same thing with Invidious, and I'll switch across here and show you how quickly it opens, and then show you the CPU usage. Copy link. Switch across. Okay. 1.
Yes, people. Well,
okay, so that's 1 there versus 1, 2, 3, 4, 5, 6, 7.
people, welcome back.
Okay. Switch back here, and I'll show you the CPU usage. -I.
Yes, people, welcome back to the Magpie Channel TV. We're just here at the George
11%, 10%. And again, I'll switch across here and do it with MPV. So Python, still not open, still not open, still not open. Now it's open. 112%, 90%. Okay, so that's the gist of everything. I'll put links to all this under the video. I need to put the link to the lag PF or some of the other files in there. And we come back across here. So yeah, that's Invidious. That's the Bhyve notes. Again, you may get better performance running a disk image as opposed to a ZFS volume device, but I haven't really noticed any difference with the setup. But the advantage of the ZFS volume is sparse volume as it sort of increases as opposed to a static size that you created. And if I just come back across to my notes, Freebsd, Invidious. Okay. Another thing to mention is that I do have videos set up using Podman on Freebsd. However, the Invidious Git repository and general setup actually uses Linux syscalls that aren't supported by the Linuxulator, and so they actually fail if you're trying to run Invidious directly using Podman on Freebsd, which is why we need to set up a VM with Ubuntu and install Podman in that for Invidious, so that there isn't any issues with it using syscalls that aren't supported, as I said, using the Linuxulator, because it's running in a, in a proper sort of virtual environment with a Linux sort of setup. I think it may be Crystal. It used something called Crystal. I think that may have been the issue. But just to give you a recap, we installed the packages. So Bhyve VM, Bhyve firmware, grub to Bhyve, Bhyve VM, Bhyve devel. We created the data sets to store everything. Remember, replace my username with your username, and then chown the directory. And so we're creating 4 data sets here, ZFS data sets that will be mounted to these locations. The main one, ISO, templates, config, and images. We set up our rc.conf with VM, nmdm, VM enabled, and the VM directory. And remember to replace my username with your username there. You run KLD load so you don't have to reboot. So does KLD load VM nmdm. You don't have to, this is only if you haven't rebooted, you don't have to do it after that. We set up the networking, does sys sysrc gateway enabled equals yes. The netlink tap up on open, IP forwarding in our sysctl.conf. We copy the templates to the templates directory. We set up DOAS. I'll have to put the link to the Makefile in here as well. When you first do this, you do, because we haven't rebooted, you do DOAS VM start. So that's only needed once we're doing the initial setup and haven't rebooted. Once you reboot, it's all set up. VM init. We got the networking. So you just need to do this once. Again, replace Lago 0 with your network device. And again, I'll put the link to the lagpf file that I use in my pf conf and all my settings, so you can reference those. We fetched the ISO into the ISO directory. Find number of CPUs. We've got the VM config, home username, VM templates, ubuntu.conf. And remember, the important thing is we got UFI, CPUs, memory, network switch public. And the important thing is what you want is disk 0 type NVMe, okay? The disk name, and as I said, I'm using a sparse zvol, whereas if you were, have a look at Marden's notes, the disk image gives you better performance apparently, but it's a static file size, so you'd use something like the truncate command to create a disk.image file, at like 60 gig or something, whereas the sparse volume kind of grows as needed, I believe. And then we've got the system context line, so we've got the graphics, the mouse, the graphics resolution, and UEF vars. If I come into VM Ubuntu, what you see is we've got console runlock ubuntu.conf uefi-vars.fd and the log. So that's where the UEFI vars fd file comes from. That's from here. So it saves the UEFI variables, basically, I believe, into that file. Okay. Then we created the VM. So vm create-t ubuntu-size. That's what the S is for. 60 gig Ubuntu. And then vm install-f to run it in the foreground Ubuntu. So that's the name of the template that's used, and the ISO file from the ISO directory. And that will bring you up through the installer where you click through. And as I said, there's one thing you don't want to select that gave me problems. I can't remember what it was. You don't want to set up an encrypted LVM because there's no point in that. But there was one option at the bottom of the screen, which I can't remember offhand, that caused issues. I just can't remember what it is offhand. But for connecting via VNC, if you're on Wayland, you can install, you can run pkg install wlr-which-key, and this is how you would use it. wlr-ncc-s 127.0.0.1 5900 is the port. If you're on X11, I think you can use Tiger VNC. And then we went through the Ubuntu setup again. Remember, we installed Git Podman, Podman Compose, pwgen, which is used in the script. We set up the registries. So that should be, because we're in the container, we're using sudo. So sudo vi etc containers registries.conf. And at the bottom of that file, we appended registries docker.io and qa.io. We edited the app armor, so sudo vi etc app armor user bin pasta. What we can also do is actually you can use emacs tramp, so I can run shush ssh loki. Is that not? Yeah, I don't know why that's. Okay. Bastard. Fingerprint must have changed. Hang on. Don't know why it's doing that. Let me just check. It's I don't know why. Yes. Okay. Loki. Oh, why is it doing that, you bastard? Tramp lean up connection. If I can get it to work, but you can use. Yeah, there we go. Now we've got it in. Sorry about that. So what you can also do is you can use emacs tramp to actually get into the container and then edit files. But anyway, back to the app armor. You edit the app armor file and you put this bit of code in under the includes profile, under the includes abstractions pasta. Put that in. Signal receive set term peer podman, and that stops errors from app armor when you're closing down the container. We use login CTL, so when you're logged in to the server, what you do is you run login as your regular user, I think it was from memory, login CTL enable -linger and then your username, and that's so that we can use the Makefile, do a one-shot command and the service will continue running. We created the Podman directory, changed into it, created the Invidious Podman directory, cloned the Git repository, and normally what you would do, as I said, you just have a compose.yaml file like this, and you could then do podman-compose up-d, and it would pull everything down. But at the moment, there's that error, and so what we had to do was apply the channel fix by changing into the Invidious directory, running git fetch origin pull the head channel fix, git checkout channel fix, then have this compose .yaml in the Invidious Podman directory. And again, that's why we have that directory structure where we've got Invidious-podman, and then the Invidious directory. Otherwise, it wouldn't be clear where files I was referring to were actually situated. And as you can see, the one difference between the regular file is we got the image commented out and just the image my patched Invidious. And then when we're in the Invidious Git repository, we ran doas build to build the my patched Invidious file. And then what you do is you make sure you're in the Invidious Podman directory. You have the start Invidious script, make it executable, and as you see here, what it does is it sets these variables with pwgen so that the passwords aren't hard-coded into the compose.yaml file, so you can upload it to GitHub. You just run start Invidious like that. This is how you log into Invidious. So remember, I won't go through all of that again. But basically, once you've got it, all that, well, the last thing I will go through actually is the SSH keys. Remember, you do SSH-copy-ID, your username @ and then the IP of the server. It'll prompt you for your password. Then you can log in like that, or actually create the configuration in your shush.config file. So you just have to type SSH host. And then what we had was the Makefile again. So recap on the Makefile. I lay them out in a particular fashion. So you got the file project. I always have headings like this, so it's easier to scan through a single line and then 2 lines underneath to make it more readable. We got the VM name, start, stop, server IP, port, remote directory, start, stop, default target all SSH. So then it runs VM. It starts the VM. It uses netcat with an until loop, checking if port 22 is open. Once it's open, it then moves on to SSH. So you can see that all these, you've got VM. So netcat depends on VM. So it only runs when VM starts. And then SSH only runs when netcat's finished. And SSH is the default target down here. So that's saying, okay, you've got to complete all the steps until SSH. So that's when it SSHs into the server and it runs the script. And then for clean, we've got the reverse. It SSHs into the server, it stops the Podman container, and then it stops the VM. Then again, just to recap, we had the wlr-which-key with the emacs command. We had the MPV set up with the conditional profile and the script for Invidious. And that's what uses the MPD file, which has got all the streams in it, and it gets the title as well. And then we had the emacs configuration. We had all the what the fuck? We had the MPV seek to point, the diode settings, and then the MPV settings for the screen, the links, was it? And the other thing is those links actually also work with or capture. So do this copy here, and if I run control C, if I do video, what you'll see here is it's automatically prepending this video. section to here. And then it gives you automatically getting the URL from the clipboard, and then you put in the link description, and then you can refile it. And then when you're in the org file that's been refiled to, you can just run Control-C, Control-O, and it will open the video with MPV. So that's what that's for. Then we had the play or append URL. And again, what this does is, let me see if I can show you this. I might as well. So what I want to do is I want to queue up several videos. So suppose I want to queue up copy link, bang, Invidious, and what I'll do is I'll just stop this. I'm not showing it on the other screen. So you can see here, why is that not coming up now? Yeah, bugger. Let me do that again. For some reason it's now not showing the doodah thingy, you know.
People, welcome.
It should be showing the time and everything. Let me just open another video. And if I bring up the Hydra, Control A, and then press E, what you'll see is I've actually got the first video playing here. And you can see because it's playing, it's actually showing the title, whereas the next video that is queued up is not showing the actual title, because the title is only acquired once the video is playing. But what it means is I can press down on the keyboard, switch to that, and it will actually open the second video in MPV without it in the same player, basically, without it stopping the whole player and then sort of restarting. So that also works with Diode as well, so that if I queue up, if I'm in Diode and sometimes, you know, you've got to restart when you get bugs like this, you've got to restart Emacs. But if I come into another video, press, so you can see here, and then if I press the Hydra, press E, what you'll see is actually it's showing the full path to the sort of the video here. So it means I can queue these up. There's also a way with Embark where you can actually select all of the videos. Was it Control? Yeah, Control, comma. I forget what the actual command was, but there's actually a way where you can actually select all the videos in a directory and then automatically add them to the playlist. I just can't remember off the top of my head what I did to do that. So rather than you going through and like clicking on one, clicking on two to load it up, if I can remember what it is offhand. Is it on the next screen or something? Find file, shell command. I think it may have been act on all. So L. Okay, it's failed to do that. Yeah, okay, well, that was another thing. But there is a way using Embark to actually select multiple files and then have them all added to the playlist. Then we've got the playback commands and everything, file hooks, and then the Hydra, as I said. And the other last thing we had was user local etc rc.d lag pf, and this is my lago interface, and again it runs that if config command, so you don't have to run it every time. So lots of bits to get through, but as I said, once I've actually gone through and got this set up, it's dead easy to actually use. Basically, as I said, I just run make, that starts the VM, starts Invidious, and with all the that set up, I can now just come across here. There is a way in what's the thing, Vimium. There's a keyboard shortcut in Vimium where you can press a keyboard shortcut and it comes up with letters, and you can press the letter and it will copy it to the clipboard, but it fails quite a bit of the time. So I just come across here, copy link, press Super Z, press I, and what it does is it then sends that URL to Emacs, which rewrites it to use the Invidious URL. It then plays it with MPV, which then uses the Lua script to get the video and audio streams, and it plays in a second, less than a second, as opposed to 8 seconds with yt-dlp and MPV, and I get 10% CPU usage instead of 117. So yeah, faster startup time, faster, much less CPU. So winner, winner, chicken dinner. And I'll put links to everything under the video. All the notes. I'll put the Makefile up there and the links to the lag.pf and all my root files and dot files and scripts and whatnot. And I'll also link to Vermaden's notes about Bhyve and any other things that I can think that might be useful. So I'll leave it there. I just wanted to go through everything completely, all the different bits that make this up. But as I said, once you've got all this set up, it's very user friendly. There may be lots of stuff going on in the back end, yeah, but I kind of like to make the front of house as simple as possible. So as I said, just copy the link, press the keyboard shortcut, -I for Invidious, bang, starts playing in 1 second on my external monitor, and I can then come across into Emacs and actually control MPV using Emacs, queue up videos, next video, stop, play, pause, all from within Emacs. So it's a nice, easy to use front end, even though there's a lot of stuff going on in the back end to get it set up. Once you've gone through everything, it's not too bad, and you've got a nice, easy to use sort of setup. There are plugins and things for, or like other tools to rewrite YouTube URLs to Invidious URLs you can have a look at. There's probably some on the Invidious GitHub page, and if I find any of those, I'll put those as links as well. But I'll leave it there for now.